Please, who started the meeting first? I think someone has taken. I don't know how the person did it. Someone is hosting the meeting instead of me hosting it. Who is the host, please?
I think I was here first too, but I don't know if I'm there.
Who has taken the hosting rights of the meeting?
This is serious.
No one is. I said, please, the host is still vacant. So.
Yes, no one is hosting it.
Okay, I'm coming.
Sorry.
Okay, so welcome back, class. So my screen is now being shared so we can continue the class. Today we are going to conclude our lectures on cost volume profit analysis. We have already concluded the chapters on single product environment. Everything we have looked at under CVP is on the assumption that the company produces and or sells only one product. But we said that for most businesses, that's not what happens. They sell more than one product. So where the company sells more than one product, how do we do the CVP analysis? And we said that last week that we employ the same tools as we have learned already, just that we modify it a little bit. So today we'll see just how it is done. So we have only a little about break-even analysis or CVP to do. Then the last thing I'll talk about is budgeting. Budgeting will end our session. Yeah. So without any question, let's go ahead. We remember the following formula. From the single product environment, we know that if you want to get the break-even quantity, the quantity of the physical good, the physical quantities of the products you are dealing with or you are selling, that you must sell to earn zero profit, to be able to pay all your costs, but you have nothing remaining for maybe reinvestment, so zero profit. The formula is equal to total fixed costs divided by unit contribution, and everybody should know what goes into unit contribution or contribution per unit. That's the formula. We also said that, so this is the quantity, the physical quantity, the formula. We also said that if I want to calculate the break-even sales, this is break-even quantity. So let me represent the break-even in cedis. So break-even sales. The formula is equal to total fixed costs divided by contribution to sales ratio. And by now, everybody should be very much okay with what stands for contribution to sales ratio. Contribution to sales ratio is also referred to as contribution margin ratio. The contribution margin ratio is a term that is mostly used in American texts. And in British textbooks and other textbooks that are British biased, you will see it as contribution to sales ratio. So they are the same things. Plus other formulas. We also learned that, well, these are the formulas if I want to get profit zero. What about if I don't want to get profit zero? Because no business has the ultimate purpose of always making zero profit. So if I want to make some target profit, let's call the target profit TP, then the formula, so break-even quantity, sorry, it's not break-even anymore because break-even is for profit zero. So we are moving beyond the quantity that gives us profit zero. So let's say just quantity that makes you get some targeted profit. So let's write it like this. It's equal to that targeted profit plus the total fixed cost divided by contribution per unit or unit contribution. And everybody should be very much okay with this formula. And we also said that if we want to get, so this is target profit, profit before interest and tax. So let me even write it well. Profits before interest and tax. So the quantity to sell to earn a targeted profit before interest and tax. It is that target profit before interest and tax plus the total fixed cost divided by contribution per unit. If you want to get the revenue equivalent of this, so quantity to produce or let's say revenue to generate, so sales revenue to generate to earn this targeted profit before interest and tax. This is the physical quantities to sell. This is the sales revenue to generate to get targeted profit before interest and tax. Then the formula is profit before interest and tax plus total fixed cost divided by contribution to sales ratio. Yes, everybody should be very much okay with this. And we also said that, so far the discussion is on the assumption that we operate in an environment where there is no government, or there is government but the government doesn't make us pay any tax. But you know that is not realistic. So let's open up to where government comes in to take tax. So maybe quantity to earn profit after tax, a targeted profit after tax. The formula is profit after tax divided by 1 minus T.
Hello, sir.
1 minus TR. Yes, Charles.
Hello, sir. Sir, please, it's Irene.
Yeah, Irene, let me hear you.
Mr. Sylvester should meet because he's giving us feedback.
Please, let's try to respect ourselves. We are all adults. We don't need to be saying this every now and then. Mute your microphone, please, I beg you. If I see anybody not complying with the rules of the class, I will just take the person out of the class. It's as simple as that. Okay, so let's go ahead. So quantity to produce and sell, or quantity to sell to earn an after tax profit, a targeted profit after tax. The formula is that target profit after tax divided by 1 minus TR plus the total fixed cost, all divided by unit contribution. And we said that this one is the converted PAT. When you divide the profit after tax by 1 minus TR, you get the profit before the tax equivalent of the profit after tax. We discussed all those issues last week. So this is how the formula is. This formula converts the profit after tax to its profit before tax equivalent. And then we even demonstrated it. That if the question says the company is interested in profit after tax of 900 and tax rate is say 10%, then that profit after tax of 900, its profit before tax equivalent is 1,000. Because if you add the 10% tax, that brought you to the after tax profit of 900, you will get back to 1,000, which was the profit before you charge the tax of 10%. So this is the formula. And then you will get the quantity to sell to earn that profit after tax. The same quantity, the same profit after tax target, the sales revenue to generate, to get that profit after tax is equal to that profit after tax 1 minus TR, TR means tax rate, plus total fixed costs, all divided by contribution to sales ratio. So you know the formulas are not too difficult to understand. They make sense. And what is beautiful about what we did was that we ourselves derived all these formulas from the income statement equation, and everybody understand that basic income statement equation. Profit is equal to revenue minus total costs. Profit is equal to revenue minus total variable cost minus total fixed cost. It is from this formula that we derived all these formulas are written on screen, so nobody should have any problem. You only have a problem if you have not read over it, you have not gone over it, you are not doing any reading. And we understand that if you go by that, then you are making a choice to fail the paper, because the paper is not going to be difficult at all. So I am pleading with you, everybody should be doing some reading. Every day read something, every day read something. If you don't understand whatever you are reading, you can search for it on the internet, you can ask colleagues, you can ask me. That's not a problem for me. Okay, so this is just a recap. You know these formulas already, and it is these formulas that we are going to modify a little bit in trying to do the multi-product break-even analysis. Hello, a question? Do I have a question from any one of you? Any question? If there is no question, please mute your mic, Florence. Florence Esibu, your mic is on. If you don't have any question, please mute it. Okay, so CVP, multi-product environment. That's the task for today. Organization sells, let's say, an organization sells Sobolo, some small business. Sobolo. Sobolo plus, let's say, bread and maybe biscuits. Let's say so. So this is what a typical small business is into. This is what it sells. Now we want to do break-even analysis for the entire business, the entire small business. We can choose to do the break-even analysis on product by product. So Sobolo analysis, bread analysis, biscuit analysis. But it will not work if you do the analysis for these individual products. It doesn't work by summing them to be for the whole organization. It doesn't work like that. So for maybe insights into how each individual product is doing, you can use all the tools we have learned so far to get to know about how each individual product is doing. But if all the products are combined, which represents the performance of the whole organization, we modify the analysis a little bit from what we have learned so far. The modification is on a key assumption that says the organization sells these three products in some fixed sales mix, some constant sales mix. This is what it technically means. Anytime maybe we sell one Sobolo, there is a fixed amount of bread that goes with one Sobolo, and also a fixed amount of biscuit that goes with one Sobolo. So it is as if they are doing something like packaged selling. Packaged selling. It does not naturally appear like packaged selling, but after selling all the individual products within a certain period, if you look at the sales of Sobolo, the sales of bread, the sales of biscuits, you can determine the ratio in which it was fixed. So it was sold. So it behaves as if that ratio on which they are sold is a fixed mix of sales between them. That's the assumption we make. That's the assumption. And it is on this critical assumption that the analysis survives. So let's say this organization, for every one Sobolo sold, 2 loaves of bread are sold, and 2, let's say, packs of biscuits are also sold. When we did the trend analysis between the sales of the 3 products, this is what we saw. For every one Sobolo sold, 2 breads and 2 biscuits are sold. It can be just anything. Sometimes they can also give you the statistics in total sales. Okay, the organization at the end of the period sold, let's say 1,000 Sobolos, 2,000 units of 2,000 units of bread and 2,000 units of biscuits. It can give you the total quantities. And you should know that these total quantities reduce back to the 1, 2, 2. If you divide by the whole of it by 1,000, this by 1,000, this by 1,000, you will get 1, 2, 2. And ratio, this is how we normally pronounce it. The ratio between them, their sales quantities, which is referred to as the sales mix, the constant sales mix. We normally pronounce it at 1:2:2. So this is the sales mix of the three products. The sales mix can also be put in percentage. The sales mix can also be put in percentage. Percentage wise, because when we have 1:2:3, then the total ratio between them becomes 1 plus 2 plus 2, which is equal to 5. This is the total ratio between them. So the share of this total from any one of them is, for example, if you take Sobolo, is 1/5 of the total. If you take bread, it is 2/5 of the total. If you take biscuit, it is also 2/5 of the total. So the total as a fraction of itself will be 5/5, which is 1. So that's the total ratio. In terms of percentage, that will be 100. So you can also calculate the ratio, the sales mix between them by doing, let's say, Sobolo, bread, biscuits. Total. Let's put a total here. Total. Okay. So if the quantity of Sobolo sold is, say, 1,000, this is 2,000, and this is also 2,000. The total will be, you can use the same 1, 2, 2. It will give you the same figures. The total will be 5,000 units sold. Then, so the ratio would have been 1,000:2,000:2,000, which is 1:2:2. In terms of percentage, you can calculate it like this. This will be 100%, or in terms of ratio 1, because it will be 5,000/5,000 times 100%. I mean, under the total column. Then we express the rest as a percentage of the total. So Sobolo would have been 1,000 divided by 5,000, that's the total, times 100, which will be 1/5 times 100%. Please calculate it for me. What would that be?
20%.
What?
20%.
20%. Is that 20%?
Yes, it's
Good,
20%.
20%. This one will be 2,000 divided by 5,000 times 100%. What will this one be?
40%.
49%.
40%.
40%. Great. And this will also be 40%. Is that correct?
Yes.
2,000 divided by 5,000 times 100%. And this will also be 40%, which will sum to the 100%, total 100%. So 20% is to 40% is to 40% is the same as 1:2 is to 2. So this basic mathematics, please, I beg you, go over it. Don't make mistakes about this, because this is the foundation. The moment you make mistakes with this calculation, you are doomed. Everything will be wrong. So this is how to compute the sales mix between them. Most questions will be silent. The questions will not ask demand for it, because it is what naturally you're required to do the rest. So you must know that even if the question doesn't say calculate sales mix, it is what you need. Without it, you can't proceed. So you must calculate it. So you have to note this very well. So after establishing the sales mix between the products, Then we begin to do the analysis, the break-even analysis, and the rest, just as we know already. And it is very straightforward. I want you to understand it from common sense perspective, so I'm taking my time. Don't be in the lecture with any form of panic. Oh, this one, it is maths, I don't understand maths. No. It is understandable more than any of the things you think you understand. Okay. So now we are saying that the products are sold in this fixed pattern. So any one sobolo sold, two loaves of bread and 2 packets of biscuits, let's say so, are sold. For 20% sales of sobolo, 40% sales of bread and 40% sales of biscuits are generated. I'm speaking the same thing. Okay, so if that is the assumption, then we can proceed with the analysis by looking at things from the assumption. If the products are sold in this constant mix, then it is as if the products are bagged. They are boxed. They are put in some box and sold at once. So when you come, we package. Maybe you take a polythene bag or we take some box. And then inside the box, we give you 1 sobolo, 2 loaves of bread, 2 packets of biscuit. Technically, that is what the assumption is saying. That's the pattern in which the products are sold. So it's as if each individual who comes to us to buy, that is the package we do for the person. So if you look at it from that perspective, then it means it's like we are selling in some bag. So let's take this to be the bag. So when you come, we have already made your bag for you. And then inside the bag, we have 1 sobolo, 2 bread, and 2 biscuits. So you buy the bag. That's what the assumption, the technical or the strict interpretation of the assumption means. If we sell in bags, then we can see each bag as we can see the product in terms of bag as a single product. Because even though we have sobolo, bread, and biscuits, they are all going into one thing, one bag. So it's like the organization sell bags. And a bag is a single product. So we can analyze the organization's break-even situation by thinking that the organization sell bags, and inside the bag we have the individual product. So we want to calculate how many bags the company should sell to break even, how many bags the company should sell to get some profit before tax, how many bags the company should sell to get some profit after tax. So if you are computing the number of bags, then we are doing the same thing as the single product environment, because we do not have, the company will not have a red bag and a blue bag. It will be the same bag because the bag is one thing. We can also, so apart from that, which will use all the techniques of the single product environment, we calculate the bags. When we get a total number of bags to sell to break even, then we will tier each bag and then separate the products, and then we will know the quantity of each individual product that should be sold to break even. So we can approach it from that side, and it will be very simple. We can also approach it from a different angle using a concept called weighted average contribution. So that is the overview. So let's see exactly what it is. Let me try to find a question, if I can get one. Let me try to find a question so we can practice with the question. Okay, so I prepared small notes for you. So after the class, I'll give you these notes. Richie. Yeah, NJB baby, why? Until I'm in front. Sorry for that. So I'll give you this material as a supplementary note. The main lecture is in the textbook that I gave you, and the multiple product environment is not there, so I'll give you this supplementary note which you can use for that purpose. So let's take this question. It's a small question example I took from a certain source. A company sells 3 products: Zoo, U, and Zoo. You can change the names, please, if the names are confusing. So these are the products. Cost and sales data for one period. So that period can be a month, it can be a year, are as follows. So between Zoo, U, and Zoo, we have this sales information, which can help us compute the sales mix between them. Sales volume in units: 2,000, 2,000, 5,000. Selling price or sales price per unit is 3 cedis for Zoo, 4 cedis for U, and 2 cedis for Zoo. Variable cost per unit is also given as below. Fixed cost for the whole of the organization for that period was 3,250 Ghana cedis. Then the question typically will ask you the last question: how many units of each of the 3 products must the firm produce in order to break even? Or simply calculate the break-even position of break-even quantity, break-even sales of this organization, the organization combined. So he's not asking you to take a single product, do break-even analysis, come and take another one. No, you have to do all of them combined. So that is what I gave you the overview of. So let's now learn the approaches. Let me see if I can write here so we can see the question straight away. Okay, they are not. Okay. So, I think I have to come here. So, on the assumption of selling in bags, it means we can. Okay, let's go back to the question again. So we have to compute the sales mix between them. I broke the question down so it can be friendly. Determine the sales mix for the 3 products. Determine the weighted average contribution to sales ratio. And then you come back to this. And I'll also speak about this because there are 2 ways you can go about this one. So let's go ahead. Determine the sales mix between the products. In terms of simple ratio, that will be 2:2:5. With a total ratio of 2 plus 2 plus 5, which is 9. If you want to use the percentage, then that will be 2,000. So let's calculate it. So for Zoo, U, and Zoo, and let's bring total. So total the quantity of sales between them is 2,000. So quantity of products 2,000, 2,000, 5,000. This is how much each of them did in terms of sales, and then the total is 9,000. In terms of normal ratio, this will be 2:2:5. 5 with a total ratio of 9. In terms of percentage, this will be 100% here, and this will be 2,000. Yes, madam.
Yes, it should be 5.
Sorry, 5. 5. Thank you very much. That means you are following. Good. In terms of percentage, this will be 2,000 divided by 9,000, or you can use the reduced. That will be simple. You can use the reduced form. 2 is the same as 2,000 in this case. This 2 is also the same as 2,000, and this 5 is for 5,000, and this 9 for the 9,000. So let's use the simple form. So this will be 2 over 9 times 100%. If you use the total figures, 2,000 and 9,000, you get the same thing. You can try. 2 over 9 times 100% will give us approximately 22%, right?
Yes, sir. 22.22.
Yeah, so let's round it down, 22%. This will also be the same as 22% because the same figures. And this will be 5 over 9 times 100%. That will give us about 55.5. So we are rounding up 56%. It means when you add all of them together, you should get this one. 22 plus 22 plus 56. Does this sum to 100% because we have rounded?
Yes.
Good. So you can go by this. This is the same as this. So if the question comes and for whatever reason it has already given you the sales mix in percentage, you know what it is. If you are comfortable working in simple fraction, you can convert this percentage to fraction. 22% is 2.2, which is like the 2. So you'll get some rounding differences anyway. That will cause slight differences in your figure. So that is what it is in terms of computing the sales mix. 2:2:5. 22%, 22%, 56% between them. Now, with this ratio, we should go ahead and calculate our break-even. So for the break-even calculation, we can calculate the break-even bags. Break-even bags. So if I say break-even quantity in bags, the normal formula for the single product. So let me call the single product formula here. The single product, the break-even is total fixed cost divided by unit contribution. Unit contribution is that we've always been dealing with one product. Here, if you are selling in bags, the bag constitutes like a single product. So we have to compute the contribution inside the bag. Just like when we're dealing with a single product, we calculated the contribution from that single product. Here, we have to calculate the contribution for the bag. And we know the bag contains 3 products: sobolo, bread, and biscuits. So we will calculate the contribution from each of these individual products, multiply it by the quantity of that product that goes into the bag. For example, 1 sobolo goes into the bag. So we multiply 1 by the contribution from sobolo, 1 unit of sobolo. Then we calculate the contribution from bread. But inside the bag, there are 2 breads. So we multiply the contribution per unit of a bread by 2. That is what goes into the bag. We do the same thing for bread. Then we get the contribution inside the bag. If we divide the total fixed cost by the contribution for the bag, then we get the total number of bags that the firm should sell in order to break even. When we get the bags, then later we will untie the bags. We will tear the bags and separate the products into their categories. Then we'll be able to know, oh, okay, for sobolo, we have to sell this quantity. For bread, we have to sell this quantity. But first, we calculated the bag because the products are sold in bags first. So the calculation of the contribution that is inside the bag, this is how we do. We first calculate the contribution for each of the products. So we have zoo, U, and zoo. Selling price per unit in the question was 3. We know the formula for contribution, right? Who can tell us quickly? What is the formula for contribution?
Hello, sir.
Yes.
Selling price minus variable cost.
Good. Selling price minus variable cost. So this is the sales price per unit 342. Then variable cost per unit 2.25, 3.5, 1.25. That gives us the contribution per unit for each of the products. Hello.
0.25.
Hello. Okay, so let's do it like that. This is 342. 3.03. So let me write 342. So this is in Ghana cedis. And then variable cost per unit is 2.25, 3.5, and 1.25. 3.5, 1.25. Because these ones are in, we have some pesos, you can also do 0.00, so you bring the pesos, just to make it more accountant like. It's the same. Then contribution is contribution per unit is the selling price per unit minus the variable cost per unit. 3 minus 2.25.
0.75.
0.75. Good.
0.75, yes, sir.
4 minus 3.5. 0.5.
And 5.
2 minus 1.25.
0.75.
0.75. Good. So this is the unit contribution from the product. Now inside the bag or the package, we have, let me do it well. So in the bag we have one, this is 2 units, and it was 2:2:5. We have 2 units of zoo. We also have 2 units of U, and then 5 units of zoo. So if you want to know the contribution in the bag, it is this contribution for one zoo. So multiply times this, then we get to know the total contribution that is attached to zoo in the bag. That will be 2 times 0.75. What would that be?
1.5.
5.
1.5.
Yes, sir.
Exactly 1.5. Okay.
Yes, sir.
Then there are two U's in the bag, and one U has a contribution of 0.5. So the total contribution from U that will be in the bag is 2 times 0.5, which is 1. There are 5 zoos in the bag. Each zoo has a contribution of 0.75. So 0.75 times 5, what would that be?
3.75.
3.75. So the sum of these gives us the contribution that is going into the bag. What would that be? 1.5 plus 1 plus 3.75.
6.25.
6.25. So this is contribution for the bag. So when you take one bag, this is the contribution that that one bag brings to the organization. And this is just how we calculate it. And it is not a difficult mathematics, it's basic mathematics. Just follow the logic. Don't chew it, please. Now that we know contribution per bag, now we know the formula for break-even from the single product to be total fixed cost divided by unit contribution. So if we divide total fixed cost by contribution per bag, then we get the total number of bags to sell to break even. That's the logic. So break even quantity in bags or break even bags, let me write it like this, is equal to total fixed cost divided by contribution per bag. Contribution per bag. In other textbooks, I am using bag because I want you to understand it practically. They would have used a term like sales mix. The sales mix is like the package, so it's the same as the bag. I'm referring to it as bag so you can understand it. So if you are reading and you see sales mix, so this will be the contribution from the sales mix. It's the same as the contribution from the bag because we are selling in bags. Now, the total contribution in the question was, the total fixed cost in the question was this. Was 3,250 Ghana cedis. And we already know our contribution per bag. So break even quantity in bags is equal to 3,250 divided by 6.25. What will this give us?
520.
520. So this is 520 what? Bags, right? So the organization needs to sell 520 bags to break even. And then you know that this 520 bags, so if I represent the bags as this is a bag, let's say this is a bag, 520 of them. 520 of them. And you know that inside each bag we have 2 Zeus, we have 2 U's, and we have 5 Zeus. The same thing will be here, up to 520 of them. Yes. Each bag has these products in them. So now we are coming to untie the bags and then separate the products. Okay, Zeus, all of you go one side. Use, all of you go one side. And Zeus, you two, all of you go one side. If we have 520 bags, how many Zeus do you think we will have?
40.
That will just be 2 times 520, right? Because for each of the 520 bags, there are 2 Zeus. Is this mathematics okay for you?
Yes, sir.
Okay, that will be 2 times 520 will be what?
1,040. Yes, sir.
Then you, also 2 times 520. That will be 1040. And then Zoo, 5 times 520. That will be what?
2,600.
2,600. Good. That will also mean that if you are interested in finding the total individual product, then it is 1040 plus 1040 plus 2,600. That will be to be about
4,680.
4,680. For what?
4680.
4680.
4680. Good. Good. Okay. So this is the total number of bags, 520. Each bag has these individual products. So we have grouped them. We have 1040 zoos, 1040 U's, and 2,600 zoos. All of them combined, we have individual products between zoo, U, and zoo of 4,680. So this is how you do it. We looked at it from the whole package. So we got the number of packages, the number of boxes, the number of bags that we can sell, 520. Inside each bag are some quantities of the individual products. So we assemble them into their categories. And then we have 1,040 units of zoos, 1,040 units of zoos, 1,040 units of U, and 2,600 units of zoo. All combined, if you mix all of them individual products between the three products, it is 4,680 units of zoo, U, and zoo. Any questions so far? You should ask me a question, I beg.
Hello, sir.
Yes, sir.
So who has a question? Let me see your hands.
And how will I raise my hand?
If you don't have a question, please mute your mic. I don't see any hand. I see microphones on. Just raise your hand and let me call. If you don't intend to ask a question, let's get your microphone off. Olivia, if you don't have a question, you can mute your mic or ask your question.
Please, a colleague is with me. He wanted to ask a question.
Okay, let him ask. Or let her ask.
So, with the zoos, use and zoo, with this question, I want to ask, since a bag contains 3 products, I'm asking why 2 bags and not 3? Because we have 3 products there.
Why what?
3 bags and not, because we use 2 bags in answering this very question.
No, the illustration, please, when I'm speaking, take your time, follow my speech more than what I'm writing. What I did here, I said the organization needs to sell 520 bags. I cannot sketch 520 bags here. So I just did 2 of them and I said bags like this up to 520. So if this is confusing, let me take it off.
Okay.
So these 2 bags I drew doesn't mean there are 2 bags. No, that's not what I was communicating. I was only saying that the bags, I was representing the bags, sketching the bags for you, and we have 520 of such bags. And then inside each bag, you know the product that are inside each bag. So it's not 2 bags, it's 520 bags. Are you okay?
Yes, sir. Yes, sir.
Yeah, good. Any other question?
Yes, sir. Please, this is Miranda.
Yeah, Miranda,
Sir,
let me
please,
hear you.
On the table, the selling price for the zoo, the last one.
Okay.
Is it 2 or 5?
The selling price is 2. It is the units.
It's
The
2.
units that is 5. But each unit of zoo sells for 2 cedis. This is the selling price information here.
Yes, sir.
Yeah.
So if it's for 2 cities, then I stand to be corrected because I didn't get the right figure.
Oh, okay.
When we go to the
So you
variable
use the wrong
cost
figure.
the variable cost per unit, we had 2.25, 3.50, and then 1.2. When we do the subtraction, we are supposed to get 0.8.
When you
For the
subtract,
contribution.
okay, let's go back to the drawing, the worksheet. Let's go back to the worksheet to clear that confusion. Okay, so we're trying to compute the individual contribution between zoo, you, and zoo. Selling
sir.
price per unit is 342. This is correct. We have confirmed from the question.
Yes.
Variable cost per unit is 2.25, 3.5, and so let's check. Yeah, this is also correct, 1.25. If we subtract 2.25 from 3, you told me the answer is 0.275. If you subtract 3.5 from 4, you are left with 0.5. If you subtract 1.25 from 2, are you saying this is wrong?
Yeah, I didn't get the figure as 1.25. I rather had it as 1.20. So
sorry.
the confusion is clear now.
So are you clear now? Are you okay now?
Yes, sir.
Thank you.
Yes, sir, I'm clear now.
Thank you.
Okay, thank you very much, sir.
Hello, sir.
Yes, madam.
Sir, please, I'm Elizabeth.
You have a question?
Yes,
Yeah,
please.
Elizabeth, let me hear you.
I'm a bit confused. I don't know where we get the unit. The unit.
Okay, let's go back to the question. This is the unit, 2,000, 2,000, 5,000. Are you okay with this one?
Yes, sir.
Good. And it means you missed what I was saying about the sales mix, the ratio of sales between them. The assumption is that the products are sold in some fixed ratio.
Okay.
So it is as if any person who comes to buy, he cannot buy just one zoo and go. He cannot buy one zoo and go. When he buys two zoos, he also has to take home 2 ewes and 5 zoos. That's the strictest interpretation of the assumption.
Okay, sir.
Hello? Mr. Facha, me were class. No, I didn't. Yeah, me were class. Maybe I'm a throwback. Why? Sorry. Yeah. Okay, sorry for that. So, this is the sales mix between them. 2,000 is to 2,000 is to 5,000. And you can work with this. Instead of the 2, let's go back to the drawing sheet, the worksheet. Instead of this ratio I wrote here, when we're computing the ratio, instead of this, I even did the 2,000, 2,000, 5,000. And I said you can reduce these bigger figures, 2,000, 2,000, 5,000, into this 225. They are the same.
Okay, sir.
2,000, 2,000, 5,000, giving us a total of 9,000, is reduced. We have just divided through by 1,000. And if you divide here by 1,000, 1,000, 1,000, 1,000, then whatever you get is the same as the previous. You have just reduced them into a lower form.
Okay.
Because when you are calculating, if you are using simple numbers, your calculation is likely to be accurate. You will make more mistakes because you are going to write less than if you are using the whole bigger figures. That is not to say that you couldn't have used this. You could have used this to do, because you come back to the same conclusions. But we reduce this to this.
Okay.
And we even say that we can put this one in percentage as 22, 22, 56%.
Okay.
Are you okay, Elizabeth?
Yes, please,
Okay.
sir. Thank you so much.
So it means we are all okay up to this point. Break it even bags to sell 520. Now we want to tear the bags and separate the product. Each bag we have 2 zoos. So we have 520 bags, and each one of them has 2 zoos. How many zoos would we have? 2 times 250. That is 1040. We have done those calculations beautifully. So they are here. So total combined, all of the products, zoo and zoo all combined, individual products will be this plus this plus this, which gave us 4,680. So this is one approach you can use to get. So the question asking us let's go back to the question. The last part of the question was, How many units of each of the three products must the firm produce in order to break even? Even though you first calculated it in bags, 520, you now have it. How many units? 1040 for zoo, 1040 for you, and 2,600 for zoo. That's it. Question completed. So this is from the package approach. We are selling them in bags. You can also say that, okay, that may be a very wild assumption. How can it be that I came to buy Sobolo, for example, and I'm only interested in buying one bottle of Sobolo? Why should I by force buy 2 loaves of bread and 2 packs of biscuits? We are trying to work everything around the assumption. The strictest interpretation of the assumption is what I have already demonstrated to you. But if someone argues that, oh, it doesn't make sense to go by it that way, even though you will get the solution, so you will want to maybe get your individual products, not first of all in bags. Individual product. I want to get an individual product because someone could have come and buy only Sobolo and gone. Someone could have come and buy 1 Sobolo and one loaf of bread, not 2 loaves of bread, and so on and so forth. So I cannot force to sell them in bags like we have calculated. So I will calculate my break-even total quantities for all the products, and then I will assemble them into their various categories. That uses the concept of weighted average contribution per. It's still the bag thing, but in some textbooks you will see per the sales mix. Sales mix is the same as the bag, so per bag, because that's what I've used. This one will get you the total number of the products all combined. That's what we had as 4,680 straight away. Then you will come and sort them into their various categories according to the ratio between them. So whichever approach you use, you will get to the destination, the same destination. So it depends on which one you judge to be a shorter route for you, then you can go by that. Weighted average. Hello, Fayad. Yeah, I'm in class. I'm from Meshi. So weighted average contribution per bag is not too different from what we have done already. Each individual product, a unit of each individual product has its contribution. But inside the bag, we cannot just add their contribution because some products are more than others. So weighted average contribution is like saying that, okay, if I have zoo, if I have you, and if I have zoo, with their contribution per unit of this one was 0.75, this one was 0.5, and this one was also 0.75, if I am not mistaken. Let's go back to that calculation. Yes, 0.75, 0.5, 0.75. That is their unit contribution. So if I have this unit contribution inside the mix, inside the bag, we have different quantities of each product. They are not one. So we have to weight these contributions by the quantities that are coming into the bag. It's similar to we have already done all those calculations, just that I'm interpreting them with a different tongue this time around. So we will do 2 over 9 times 0.75. This is your weighted contribution. We are giving the weights from the quantity that you are bringing into the bag. We are weighting your contribution by the quantity you are bringing into your bag. You do same to this. This is also 2 over 9 times 0.5. And this was 5 over, or, yeah, it was 5. 5 over 9 times 0.75. So if you do this, you sum these weighted contributions, then you get the weighted average contribution for the bag. So let's do it. 2 over 9 times 0.75.
0.166.
0.166. Is that all?
167.
6666666. Sometimes that's a problem. If we round, we get slight differences. So let's do it like that. Plus 2 over 9 times 0.5.
0.11111.
0.111, like that, going. And this one, 5 over 9 times 0.75.
0.416667.
0.41
66667.
66667. Good. So if you are using a scientific calculator, there's a way you can key the whole of this in brackets, plus the whole of this in brackets, plus the whole of this in brackets. So you wouldn't go into rounding at this level. Then you will get the total answer before you can round. But let's try to add, even though we have rounded. So let's say this is 0.6, let's say 0.17, 0.11, and this is 0.41. Let's add them.
0.693.
0.693.
693. Yes, sir.
Okay, so that's the sum of this and this and this, right?
Yes, sir.
Okay. Another way of simply calculating this weighted average, I just wanted you to show you this because we are learning. The simple way to calculate it is that you have already calculated the contribution of the bag from the earlier calculation, which was each product contribution multiplied by the quantity that is going into the bag. This one. This one. This was the individual contributions, and then we multiplied by the quantities that are going into the bag, 225, and then we got this, then we got the total contribution for the bag. See this, 225. What we are ignoring about this thing we have already done, what is missing from here compared to what I was just teaching you, the weighted average contribution, is the over 9 over 9 over 9. Have you seen that? Let's go back to the weighted average. 2 over 9 times your contribution, because you brought 2 out of the total 9. 2 over 9 times your contribution. 5 over 9 times your contribution. This is what we are doing in terms of calculating the weighted average contribution for the bag. And I'm saying that we did almost the same thing when we were calculating the contribution for the bag, which we divided that by the fixed cost to get the break-even bags. What is missing from here is the over 9 over 9 over 9. Otherwise, I am doing the same thing again. So it means that this one we got without the over 9 as 6.25, 6.25. The denominator between them is a common one, 999. So if I divide this by 9, I get the same thing that I was trying to do by that long calculation. 6.2 divided by 9 should give you this around the same, because if there will be any difference, it's because we rounded. This one, the weighted average contribution of approximately 0.69.
Yes, I said when you divide the 6.25 by 9, you get 0.694444.
Good. Because we have rounded here, you will get that slight difference, but they are exactly the same. So you get this one to be 0.69. Is that what you said?
Yes, sir. 0.69444444.
So let's say 0.694. 0.694. Because of rounding issues, you will always get some small differences. For example, if someone has rounded this figure to 2 decimal places as 0.69, another person is using 3 decimal places, 0.694. Another person can even use 4 decimal places. Someone can even use all the digits on his screen. The one who has used all the digits on his screen will get absolutely the perfect answer. But because of rounding, you will be having small differences. That doesn't make your answer wrong. You are 100% right. So this is the weighted average contribution for the bag. You can calculate it as the total contribution of the bag divided by the total number of units in the bag. You can also calculate it by this formula. Okay, for every product, this is your contribution. We are weighting your contribution by your representation in the bag. Your representation is 2/9. Your representation is 2/9 times your contribution. Your representation is 5/9. You have the biggest representation. When you sum all of them, you get a weighted average contribution. Thank you. So 0.694 approximately. When we have this weighted average contribution, then if you divide, the formula is break-even quantity. This one is not in bags. We want to calculate the individual products all combined, after which we will sort them. The first approach, we calculated them in bags, and then we tier the bags to separate them into their categories. Please get the understanding. So break-even quantity would now be equal to the total fixed cost divided by this weighted average contribution for the mix or for the bag. And this will be 3250 divided by 0.694. What will this figure be? It should be approximately that same figure you got. What will this figure be? I'm waiting for your response. What will this be? 3250 divided by 0.694.
4682. 82.999.
82.99. Okay, let's see something.
I had 4680.
You had what?
4680.
Please, can you speak out? I can hardly hear you.
4680.
Good, 4680. And see this figure, because he used all the decimal places, so he'll get the exact value. See this figure. That's the same figure you had here. Sorry, I think when we got the bags 520 and we separated them 1040, 2600. When we added them together, have you now seen we had the same thing, 4680? Yes. So if you go by the weighted average contribution for the mix approach, you will first of all arrive at this figure. So this is the figure for all of the product mixed together. We have added all of them. 1020 from ZU, 1040 from XU, 1040 from YU, and 2600 from ZU. We have put all of them together. They give us 4680. The first approach, the bag approach, we were not interested in getting all of them mixed up from the start. We got the bags, so we had 520 bags, and then we tiered the bags, we get the bags torn out, and then we separated, and then we had this. When you have the separate units and you add them, you will come and get this unit. The weighted average contribution approach will make you land here for the first time. The total units for the 3 products combined, and then you will sort them into their categories. So that's what we have gotten. In case you had a slightly different figure from this, it is purely as a result of the rounding. The roundings that we have been doing. So if you like, you can use all the decimal points on your calculation. You will come and get exactly 4680. Okay, so now 4680 between XU, YU, ZU. It's for all of these things combined. So how do we group them? For this one itself, this one itself, and this one itself separately. So you use the ratio in which they were sold. They were sold in the ratio of 2:2:9, or 2,000, 2,000, 9,000. Hey, 2:2:5. A total of 9. Or 2,000, 2,000, 5,000, a total of 9,000. To split it between them. So it means for ZU, his representation in this total figure is 2/9. This one, his representation is also 2/9, his share of this total, and this one is 5/9. So now let's come down. 2/9 times this. What do we get?
1040.
1040. This will be 1040 as well, and this will be 2600.
1040.
Yes, just like you got in the bag approach. So we have used 2 different approaches, but we have come back to the same destination. It is for you to decide which of the routes is shorter for you or more comfortable for you to adopt. But of course, you can learn the 2 so that you can be versatile. Yeah. Any questions so far? I am waiting for your questions, please.
Hello, sir.
Yes, madam.
Sir, please, you said the formula for the weighted average is contribution per bag over total.
The total units of the products in the bag. You remember within each bag we have 2 XUs, 2 YUs, and 5 ZUs, right? So the total unit combined in the bag will be 2 plus 2 plus 5, which is 9, right?
Yes, sir.
Yeah, so you divide the contribution for the bag divided by the 9, which is the total number of units for all the 3 products inside the bag.
Yes, sir. Thank you, sir.
Okay. Okay, so if no other question, then let's proceed. So this is just what you do to calculate the break-even quantities for all of the products combined, 4,680, and this is how you separate them into their categories. You could have also done it with the bag approach, the total number of bags, and inside each bag you have the quantities of the individual products. You separate them into their individual categories. All the approaches are fantastic. It takes you to the same destination. Now, if we want to get right now we have the physical quantity, so this will be 1040 XUs, 1040 YUs and 2600 ZUs. Just like we did for the single product environment, after getting the quantity, we are also much interested as accountants or as managers, the money side of the things. It's not only the physical quantity of the product. So what money is it bringing? So I know my break-even quantity. What is the break-even revenue? That is also very much needed. So you can, you know the basic formula, you can multiply this quantity for each quantities for each of the products by their selling price. So the selling price for this one was, I think 3, this one was 4, and this one was 2. Let's go back to the question to confirm. Yes, the sales price per unit is 342. When you do the multiplication, you will come and get the sales revenue for each of the products. And if you sum the sales revenue, you will get the sales revenue for all the products combined. That's for the whole organization. 1040 times 3 will be what? Hello? This one, quick. 1040 times 3.
3120.
3120, good. 1040 times 4.
4160.
4160.
4160.
Yes.
2600 times 2.
5200.
5200. Good. So this is they are all in Ghana cedis. This is the sales revenue to generate for all the product or for each product in order to break even. So the break even sales for all the products combined will be 3120 or 3120, 4160 and 520, the sum of these products, the sum of these figures. So this plus this, what would that give us? 3120 plus 4160 plus 5200. What's the sum?
12480. I hope I got it right.
14560.
1450.
4560.
560.
Yes, sir.
Please, should I take it to be correct? This plus this is equal to 14560 Ghana cedis.
No, 32. No, that one.
340.
340.
Why can't you do summation of these three for me?
I had 124.
Exactly. That is what I said. 12480.
12480.
Like this.
Yes, sir.
So who had that different figure? Please check your calculation, or if it is punching something else, make we see it for you before it gets too late. Okay, so this is the sales revenue to break even for the whole of the organization, and this is for the individual products. We have to generate sales revenue of 3,120 for XU, 4,160 for YU, and 5,200 for ZU, and then all combined is 12,480. Any question? Okay, so this is the basic way of calculating the break-even sales for each of the products and for all the products combined, as I have illustrated on the screen. You also do remember that to get this same figure straight away in a single product environment, we use a certain concept called contribution to sales ratio or contribution margin ratio. They are the same. And then we said that the contribution to sales ratio, which will make us get the sales revenue straight away, is equal to unit contribution divided by unit sales or selling price per unit. This gives us contribution to sales ratio, also known as contribution margin ratio. This is for the single product environment. Single product. For multiple products, we modify this formula a little because of the constant sales mix assumption. So in fact, what we do is we calculate weighted average contribution to sales ratio, just like we calculated weighted average contribution for the mix, the 0.694. That one was to help us get the physical quantities. To get the sales revenue straight away, we calculate. Yes, question? Yes. I'm listening. Is someone asking a question? Yes, sir. Good morning. Okay, so please do well to remind yourself to put your mics off if you after using them. So contribution to sales ratio for single product environment, this is what it is. For multiple products, we calculate what is called weighted average contribution to sales ratio, or you can simply say weighted average CS ratio. CS for contribution to sales ratio. In American textbooks, you will see it as weighted average contribution margin ratio. It's not different, it's the same. How do we calculate it? And here in multiple product environment, you have to be, just like in a single product environment, you have to be very particular. Quantity goes with quantity, revenue goes with revenue. And this is what I mean. When we were calculating the break-even quantity, the ratio between the products, the sales mix, was the physical quantities. This one is 2,000 units. It's not 2,000 Ghana cedis. 2,000 physical units, 2,000 physical units, 5,000 physical units, giving us a total of 9,000 units. They are not cedis. So when you are calculating the quantities, break-even quantity or whatever quantity, once it is quantity, the sales mix should be based on the quantities. If we are now coming to the revenue side, break-even revenue or whatever revenue, we have to use the revenue, the ratio of revenues between them, not the quantities. If you use the quantities, you get it wrong. You are mismatching. So here, we have to get the sales revenue for XU, the sales revenue for U, and the sales revenue for ZU. And then we compute the ratio based on the sales revenue. And you can simply do that. Based on the physical quantities of 2,000, 2,000, 5,000, and then the information on selling price per unit, you can simply calculate the sales revenue. So let's try to do that. XU, YU, ZU. Quantities: 2,000, 2,000, 5,000. Let me bring the total. Okay, so I think let me bring the total here. It doesn't spoil anything. Total is 9,000. Then selling price per unit. This one was 3, I remember. This is 4, and this is 2. Giving us sales revenue of 9 times 3. Let me confirm. Selling price.
Hello,
342. Yes, madam. Ask your question.
Sir, please, you have stated the same price for zoo and at the total.
Sorry, I beg. It's because of where I brought the total. Thank you very much. So this is not aligned well. So it is 342. Thank you very much. This one will give us 6,000, right? Check the figures. This one will give us what? 8,000.
8,000.
And this one will give us 10,000.
10,000.
Giving us a total of what? 6 plus 8 plus 10.
24,000.
24,000. So this is sales revenue in Ghana cedis. So now we are going to compute the mix between them using this. The sales mix between them using this. On the surface, it means it is 6,000 is to 8,000 is to 10,000, all in Ghana cedis. But if you can reduce them to some smaller values, smaller equivalent values, that will be fine. If you divide here by, let's say, 2,000. If you divide through by 2,000, you will get 3 is to 4 is to 5. Is that correct?
Yes. Yes.
Yes.
Yes.
Sir, please come again. How did you get the 2,000, 2,000, 2,000?
In fact,
They are reducing it.
You try to, you know, these figures are very big. Of course, you can use the 6,000, 8,000, 10,000. Just that your figures will be bigger and you have to be doing some more calculation. So you try to find their equivalent small values. In trying to find equivalent small values, you try to pick any number which when you divide by these figures, you get round figures, you don't get fractions. So when I was thinking through my head, I thought 2,000 will do it. Yes, sir. Is someone asking a question?
Sir, please, about the 2,000.
Your link is weak. I can't get what you're saying.
2,000. If zeros each. Wow. I'm saying to clear any doubt, and then to clear any doubt, we can take the 3 zeros from each figure, 6,000, 8,000, 10,000.
Yes, that mathematics, you can do it in so many ways. It's just that maybe the person who asked the question lacks those fundamental mathematics. You could have divided first by 1,000. What he is saying, like removing the 3 zeros, is dividing by 1,000. You are not just removing the zeros. The actual thing you are doing is you are dividing by 1,000. So if I had divided by 1,000 first, which would have made me go 2 steps. This one, let's say by 1,000, by 1,000. That's the meaning of removing the 3 zeros. You can't just remove the 0. In mathematics, you have to divide or multiply. So we divide by 1,000. This will go. So we'll get, this will be 6 is to 8 is to 10. And you still see that you can reduce this number further down. If you divide here by 2, here by 2, and what you do across all of them by 2. Then the 2000 comes in because you have divided first by 1000 and then now by 2. Multiply the 2 by the 1000, it is 2000. So you could have skipped the other step by just dividing, sorry, not multiply, dividing straight by 2000 to reduce the numbers back to their barest minimum. If you divide here by 2, you get 3, here 4, and here 5, which comes back to 3 is to 4 is to 5. So Wahima, what we are trying to do is to reduce these figures down to smaller figures without changing the figures, so they are the same. 6,000 is to 8,000 is to 10,000 is equivalent to 3 is to 4 is to 5. I don't know how best I can explain that mathematics. Maybe we need to find your basic school math teacher. If he didn't teach you, we'll go for a balance. Okay, but I hope you are okay now. Are you okay? The person who asked the question.
Yes, sir, I am.
Okay, so the
Thank
2000 is not any figure from anywhere. We just thought that, oh, if you divide, because we will do it across all of them, it means you have not changed anything. If I had divided here by 2000 and then here by 1000, then we are not doing the same thing. That one we are modifying the figures, we are altering them. But if I divide here by 500, I divide also here by 500, I divide also here by 500. Whatever figures I get as a result, they are the same as the previous figures, mathematics wise. So that's why I chose 2000. So 2000 will make me reduce the numbers to some smaller numbers without any fraction. So dividing by 2000, or like he suggested, you can remove the 3 zeros, you get 6 is to, remove the 3 zeros is divided by 1000, 6 is to 8 is to 10, which can further be reduced. So 2000 will give us 3 is to 4 is to 5. This is the total ratio between them. You could have also done the percentages approach. The total is 24,000, which is 100%. Then the percentage of this, of the total, is 6,000 divided by 24,000 times 100%. And that would have given you what? 6,000 over 24,000 times 100%. Give me the figures quick, please.
0.25.
Hey.
25%.
25%. Good. So it's the same as 0.25 in fraction, but we want percentage. And then this one would have been 8,000 divided by 24,000 times 100%. What will this be in percentage? 33.3333. And that's where the problem comes from. So if you say 33%, it means that here will short some fraction, and then it will go to the other one. Okay, so let's say 33%. This one would have been 10,000 divided by 24,000 times 100%. So what would this be?
41.67.
What?
41.67.
41.67. So 42%. Yes. So when we add, we should get 100%. Please try to do that if you will get 100%.
42.
25 plus 33 plus 42.
It's 100.
Okay.
Yes, it's 100.
But you have to be aware of this slight problem of rounding. So this one will short some coins because we remove the 0.333, and this one will gain what this one lost. So that is where the shifting will be. But if you add all of them, because they will sum to 100%, the total will still be correct. Okay, so either you use this, and this one gives us, I think there is no rounding here. So I prefer to be using the normal ratios instead of the percentages, because sometimes the percentages come with some roundings. I don't like the roundings. It will make your figures not be too accurate. And Mind you, we are dealing with money. So those few percentages, like the 0.33 that we have dropped, its translation in terms of cedis or dollars can be substantial, and we don't just throw money away. I've thrown 0.33 away, and even if I've not thrown it away, because this one is gaining it's like shifting monies from one product to the other unnecessarily, and that will blur any analysis we do about the product's performance. So I think this will be more appropriate. The 3:4:5, because it doesn't have any shiftings from one product to another. Good. So with this ratio, it's the ratio of sales revenue between them. I am repeating this. If you are doing the quantities, the ratio, the sales mix, use the physical quantities. If you are now coming to the revenue, you calculate the sales mix based on the revenue between them. So we calculated the revenue by multiplying the quantities by the selling price, and then we have stricken the ratio between them as 3:4:5. Do you see that this new ratio based on revenue is not the same as the one based on the physical quantities? And that's the more reason why, if you think every ratio is ratio because it's the same product, that's where you'll be wrong. The first one was 2:2:5, a total of 9. This one is 3:4:5, a total of what? 12. Good. So just be careful about that. I know you will not forget. So now that we have this sales mix between them, then we calculate the total revenue inside the bag. It's the same exercise we have done. If you remember, when we're calculating the quantity, the break-even quantity, the bag approach, we calculated the total contribution in the bag. And then when we wanted to get the weighted average contribution per the bag, we divided that total contribution in the bag by the total number of units in the bag, and it was 6.25 divided by 9, which gave us 0.694 approximately. Hello. Yeah, me kwa kutosi ya nchi bia me. Okay, so that is the issue. So let's try to complete what we are doing. So we can calculate the total revenue in the bag and divide it by the hello, Papa. If I told maybe CCA, so you can hold on when I open some here BCCA. There, sorry. I'm going to use my card, sorry. Okay. So when we calculate please give me about 2 minutes. So when we calculate the contribution in the bag and we divide it by the sales revenue in the bag, we get the weighted average contribution to sales ratio. Let me take it again. The first one, which was weighted average contribution for the bag or for the mix. We did contribution of the mix or of the bag divided by total units in the bag, and that was 6.25 divided by 9, which gave us that. This was the weighted average contribution, which will make us get the physical quantities or the physical bags. The weighted average contribution for the bag. Now we are calculating weighted average contribution to sales ratio for the same mix, for the same bag. This one is also called weighted average contribution margin ratio. This is how Americans call it, weighted average contribution margin ratio. The same as weighted average contribution to sales ratio. Is the same as the contribution in the bag, but this time round, just like in the single product environment, we divide by the sales revenue divided by sales revenue in bag. Look at the difference. This was the total units in the bag, 9 physical units. That 9 physical units, we want to know their revenue equivalent. So the total revenue in the bag coming from the 9 units. Then this gives you the weighted average contribution to sales ratio. Once you get that, if you divide the fixed cost by that, you get the sales revenue straight away. That's all we are trying to get. So contribution is already calculated at 6.25. If we divide the 6, now let's get a total revenue in the bag. Total revenue in the bag. We have zoo, U, and zoo. This one has 3. Let's go back to the ratio of this one has so physical quantities. We can even use this one, physical quantities. This was 225, and then you can multiply by the sales revenue. Inside the bag we have these quantities going there, and each one is selling for 3, 4, and 2. The total is 9 for here. So if you multiply each of the units in the bag by their sales price, this will be 6, this will be 8, this will be 10, giving us a total of 24. So this is the total sales revenue in the bag.
Hello, sir.
Yes, madam.
Please, the sales revenue under the zoo, you have written 2.
Hello, please come again.
Sir, for the sales revenue under the zoo, you have written 2. And if you are using the sales ratio, it was 3:4:5.
Yes. Yes, I'll come back to this. 3:4:5, right? But what I'm trying to do right now is Inside the bag, we have 2,000 physical units of ZU, 2,000 physical units of YU, and 5,000 physical units of ZU. Each of XU is sold for 3 cedis. So you can calculate the total revenue that each one is bringing and all of them combined in the bag. That's what I'm doing now. The one I computed is the sales mix between the 3 products based on their sales revenue. I'll use that one to show you an equivalent way of calculating the weighted average contribution to sales ratio. But what I'm doing right now is one of the approaches, in fact, the shortest of it. So we are calculating the sales revenue that goes into the bag, because the formula of weighted average contribution to sales ratio is contribution of the bag, and all of us can calculate contribution of the bag. It's contribution of the individual products multiplied by each unit the product is taken to the bag. That gives you the total. If you sum them, that gives you the total contribution for the bag. Then if you divide it by the sales revenue in the bag, the sales revenue for all the product combined in the bag, that gives you the weighted average contribution to sales ratio. So that's what is making us calculate this. You could have used the gross figures, 2,000, 2,000, 5,000, 9,000. But the smaller figures are preferable. So 2 XUs are in the bag, 2 YUs are in the bag, 5 ZUs are in the bag. Each XU sells for 3. So inside the bag, the sales revenue from XU is 6, 3 times 2. Each YU is sold for 4. So inside the bag, YU is bringing total revenue of 8, 2 times 4. And the same thing is done for ZU. And then when you add their sales revenue together, you get 24. If you had used the gross figures, you would have seen that you would have gotten 24,000. If you remember, 24,000 was the total sales revenue for them, which we splitted into the 3:4:5. So now this total revenue in the bag, if we divide the contribution in the bag, so weighted average contribution to sales ratio is equal to contribution of the bag or in the bag, whatever, divided by revenue in the bag. This will give us 6.25 divided by 24. If you had used the gross figures, you would have had maybe this one in thousands, also this one in thousands. But they will cancel to give you the same value. So 6.25 divided by 24, please, what would that give us? I want us to write all the decimal places because I want to confirm that it is equivalent to the first approach we did. So this will give us what?
0.2604.
0.2604
16667.
16667. How many
Yes.
6?
4.
0.24
0.2604.
0.260441.
16667.
Okay, 66667. So let's say 67. So this is the weighted average contribution to sales ratio. If we divide the fixed costs, so sales revenue, break-even sales revenue, will be equal to the fixed cost of 3250, I think that's correct, divided by this 0.260416667, whatever. So divide it. Divide 3,250 by this figure. we should get the same or almost the same as the 12,480 that we had by adding the separate revenues. This is what I'm...
So 12,480.
Yes, you remember this one. The separate revenues were
Yes.
3120, 4160, 5200. If we add them, we get this. Yes. But I said that instead of going by this approach, this is the physical quantity. This is the physical quantity, and this is the selling price. Then it gives you this, the revenue, we add them. The weighted average contribution to sales ratio will make you get this figure straight away. And that's what we did. And then we have gone through all the procedures in calculating the weighted average contribution to sales ratio. That is the contribution in the mix or the bag divided by the total revenue in the bag. 0.2604167. When you divide the fixed cost by that, you get 12,000. What was it? 12,480. Yes. So this one gives it to you straight away. And then, if you want to know, this is the total for all the three products combined. So if you want to know the portion that goes for XU, YU and ZU, then you use the ratio, the mix, the ratio between them in terms of sales revenue, the one that we calculated, the one that Madam was asking the question about. You use this, 3:4:5. If you don't take care, you will go and use the 2:2:5, which will be wrong. We share revenue based on revenue ratio. We share physical quantity based on physical quantity ratio. So now the 12,480 splits according to their ratio, their sales revenue ratio of 3:4:5. So let me do the schedule. We have XU, YU, ZU. Let me even bring the total here. XU's representation of this total. Because, okay, let me write the total ratio. So ratio is 3:4:5. Is this correct? Giving us total ratio of 12. Please confirm the figures for me. Yes.
Yes.
Okay. So, Zoo's share is his representation of the total 12 of the amount we are sharing. This will be 3/12 times 12,480. What would that be? And it should be the same as what we did. So it should be the same as 3120.
3120.
So, but check for me. 3/12 times 12,480. What's the value?
That's correct. 3120.
3120. And see, the first approach, we got this 3120 before we came to get the total 12,480. This new approach of weighted average contribution to sales ratio, you will get this, and then you have to split them back into the product. The splitting is done on the basis of the ratio between them according to their sales revenue, not according to the physical quantities. That's where I want to put a stress. And this one will be 4/12 times 12,480. This one is what? It should be the same as the first one, but calculate it here. I think it was 41 something. 4160.
41.
150.
Okay, and this one will be 5 over 12 times 12, 480, which will be 5200. Okay, when you sum, you get the same total we have shared. So this is basically most of the things that we need to know about multi-product environment CVP analysis. Multi-product environment CVP analysis. What we have not done is, this one is the break-even analysis. So we are not asking ourselves, okay, in case we want to get beyond profit zero, we want to get beyond the break-even profits. Like we did for the single product, if you want to earn some targeted profit, then the formula is the same. You just add that target profit to the fixed cost. So for example, this same question, if the question asks you, let's go back a little bit. If the question asks you, okay, so let's do something with this one. We know that the physical quantities of each of the product to produce 1040, 2, 600 of each of the product to produce, to sell, to break even. What if the question says, what is the size or what quantities of XU, YU and ZU should be produced? What quantities of these products should be produced? If the firm intends to get a targeted profit before tax of, let's say, 1,000, it can be any amount. Then you know that the only thing that is coming in is that you add the fixed cost. So for example, if you are approaching it from the bag approach, so you'll be asking what quantity of bags to be produced to get a target profit of, let's say, 1,000. You add the 1,000 to this, and that will take you to the number of bags. If you add 1,000, it means the number of bags will now go beyond 520. Then you you separate the product from the bags into their categories. Then you get how much of each of the products to produce and get that target profit of 1,000. If tax come in, it doesn't change anything. If tax come in, then you know we can convert the after-tax profit of this. This is profit before tax. So if they had said after-tax profit of 1,000, then the formula would have been this 1,000 divided by 1 minus the tax rates plus the total fixed costs before you divide by the contribution of the bag. So that will give you the number of bags to produce to earn that after-tax profit. And then you later separate from the bags into the categories of the product. So we have learned everything about cost volume profit analysis, single product, multiple product. Any questions so far? Question? If you have a question, please raise your voice a little so I can hear you well.
Yeah, hello.
Yes, sir, Raymond.
Yes, I will advise that when we meet face to face, if you have time, you can probably give us practice questions.
Of course, I'll give you practice questions. Then face-to-face time, we will work together. Face-to-face time will be more interactive. So people will come to the board, work, explain to us. We will all ask questions. When you come to the board, it's not like we want to see how intelligent you are or how dumb you know. That is far, far beside the point. So we will all give ourselves the opportunity to interact with ourselves with the intent of trying to understand what we are doing. So we'll do that. Before that, I'll put this information. I'm recording the lecture, so it will be available on your platforms. I'll also put the small notes I've gathered around it on your platforms for you. And then I'll add questions around this so that you can practice ahead of time before we meet face to face. Last thing I'll talk before we close is how to model all of these things we have done in a spreadsheet, because that's what you have to be doing as managers. And before I forget, please, the spreadsheet class that we are agreeing to do after the exam, I will beg that you take it serious. Don't always learn for grade paper. A4 sheet of paper with the ink they put on it as a certificate for you. You shouldn't buy it at the cost you are paying and at the time you are spending. You should get a value for the money you are paying and the time you are spending. So let's try to learn something that will make our jobs and our own lives improved. So I entreat you to take it serious. If all of you can enroll, that would be fantastic. Yeah. So let's see how we model the same. What we are.
Let me.
Question?
Let me add something small to this. Hello.
Listen, but the rest can keep quiet so we can listen to the question. Hello.
Yeah, people are making noise, bro.
Hello, I have so many of you with your microphones on. Can you please put your microphones off if you are not speaking? Sylvester.
Yes, sir.
Sylvester.
Yes,
Do you have a question? Sylvester, do you have a question?
Okay, so I think I can go ahead. I'm only adding to what our lecturer has said. We have a WhatsApp platform that people have already enrolled to. And this training will take effect after exams. It's very, very, very important. Almost 20 people have enrolled into. So if you are not aware, kindly see me if you are interested. Can you see me so that you can register for it? Because the package is very good and it's something.
Hello, the class is very noisy. Please, can we bring in some order?
Please meet your mic.
Hello, which people are having discussion outside the class? Please, you can meet your mic and do your discussion.
If they are refusing, can we take them off?
Sylvester.
Okay, so now let's try to conclude. I said we can model what we have done, all that we have done in spreadsheets. And of course, this is for the knowledge building. If you have to employ this tool in any analysis you will do, the basic, yes, Lizzie? Lisbeth, Lizzie? Lizzie, your hand is up. Let's hear you.
Which of the Lizzies?
The Lizzie with her hand up. All of you have your hands up.
And from the beginning I was getting you, but as we move from page to page, go here, move here,
you are confused.
Yeah, but from the beginning I understood.
So I beg you hold on to the beginning understanding you have.
From page to page.
Hold on to the beginning understanding you have, or that one too you have lost it.
No.
Okay, that is fantastic. So when we meet face to face, we will build on your initial understanding and everything will be over. And I even think before meeting face to face, when you go home, try to go through the notes. The textbook is already with you. the single product environment, go through them. The foundation is the same. Then go over this lecture. I will upload the video after the end of the class. Go over the video. Take your time. It's because, you see, we have different paces of understanding. And probably your pace might be a little lower than the pace I'm doing, because we are doing things with time. So if you do it at your own pace, you go over the lecture by watching the video at your own page. You can pause, think about it. You will see that it is very simple to understand. So I want you to do that after the class. The understanding will come. Okay.
All right.
Is that okay?
And then,
Yes, sir.
yes, and this, I think that this topic can also be found in chapter 10
Yeah.
of accounting, cost and management accounting book. So you also don't have a copy.
Sure. So after today, I think the time will permit me to do only what I've done so far. We have one more topic, budgeting. So we will tackle that one also as part of the face-to-face business. So the face-to-face will be for that topic plus a review of all that we have done in the form of tutorials. So that's the nature of the face-to-face. That's why I want you to schedule it outside the calendar. So it's like we have ended the university calendar with this lecture. So you can do your own timetable, make me know. So I give you my input as well. That will be for the face-to-face. Yeah. Let's do how we model what we have done with Spreadsheet. I'm going to use a relatively simple example so you can understand. In spreadsheet modeling, there is something we call sensitivity analysis, also known as what if analysis. And to be able to take huge advantage of that, we always separate the model from what we call input variables. There are some key variables that can change, or we will want to simulate. If it changes to this, what becomes the issue? If it changes to that. So we capture those figures outside the main model. The main model we'll be doing. So for CVP analysis, we said from the beginning that we want to know the relationship between, if you are not asking a question, let your mic be off. We said I want to know the relationship between cost, volume, that is quantity, profit, and revenue, how they relate. So that, okay, at this quantity, what profit do I have? At this quantity, what is the revenue equivalent? Or which revenue gives which profit, and so on and so forth. That's what we've been doing. And you can convert all of these into equations and then model them in spreadsheet. Not necessarily equations. You can use the figures and then you can show them in spreadsheet. So let's see. We will need our selling price. After I type, I'll zoom for you to see well. Selling price. We need our selling price. We also need our variable cost per unit. And all of these things, you know them. Variable cost per unit. And if you like, you can say you also need your fixed cost. If you're not asking a question, let your mic be off. Okay, so these are input variables. Then we are now coming to do the modeling. We want to know at various quantities. So let's do quantity. At various quantities, what our total sales revenue will be. So total revenue total variable cost total variable cost.
Oh, Sylvester, can you now feel like that is 7 hours?
Hello, sir.
Yes.
Please, which one is this one? Is it the budgeting that you are doing?
No, I'm doing spreadsheet modeling for the CVP analysis we have done. You will see it very soon.
Thank you. Okay.
Total fixed cost And let's say last and total cost. We can even add net or operating income. This is what I have done. This is what it means. Let me try to zoom. This is what it means. Let me put this in color. These are the input variables. So coloring. Okay, so these are the input variables. We want to know at various quantities. So quantity can start from 0, 1, and then we can fill the series for this. Or let's make it as it will be too plenty. So let's do it in 0, 10. So 0, 0. Let this one be 10. Let's do it in sequence of 10. 10, 20. So I can drag up and do for, let's say, about 400. Okay, once you are using spreadsheet, you can even drag up to about 1,000, or let's do for 500, something like it. No problem. Oh, why it didn't? 10, 20, 30, 40, 50, 60. Okay, then at these quantities, what will be our total revenues? The key figures we will have our eye on is at what quantity do we break even? At what quantity do we make certain profits? That's why I have the operating income here. You understand? So total revenue, total revenue formula. Total revenue formula is equal to sales or selling price per unit times quantity. So that's the formula that we are going to put here to generate those figures. And we have the input variables. So here is a formula is equal to selling price per unit. Okay, I have not fed the figures. So let's assume that our selling price per unit is 100. Our variable cost per unit is 60. And then let's say our fixed cost is, let's say 20,000. It can be any figure, we can change them. And let me make it accounting like. So this. Yeah, so here is equal to selling price per unit, and then you understand we have to make this an absolute cell reference. Okay, so when you press on the F4 key, it converts the relative cell into an absolute cell reference. If you want understanding of more of these things, that's the more reason why you need to join the class. So this becomes an absolute cell reference, and you have to know why we have to make it an absolute cell reference. Times quantity. Quantity will not be made an absolute because when we drag, we want it to be picking the various quantities. But when we are dragging, the quantity, the selling price should be fixed as it is. That's the meaning of what we have done. Okay, so this is 0 in accounting, that will be dash. When we drag, it automatically calculates all the sales revenues for us. These hashtags you are seeing means that the width of the column is smaller. So you can double click the column heading lines to just resize them. Okay, so okay, I will do them. So that's the total revenue. Total revenue at quantity 0 will be 0. Total revenue at quantity 10, given the selling price of 100, will be 1,000, and so on and so forth. We come to total variable cost. It is equal to variable cost per unit, which will also be an absolute sale reference, times quantity, because it varies with the level of output. That's why it is a variable cost. So this is what it will also be. You drag just as we did for the other one up to the last quantity like this, and then you get it. Is the variable cost. You can even, before our fixed cost, add this column called contribution, so you can calculate your contribution straight away. Contribution is selling price minus, so this is equal to this, that is revenue minus variable cost. This is our contribution, and this is our contribution up to the last figure. Total fixed cost, this one is equal to this, and it is an absolute sale reference. The reason why I did it the way I did, I put it here and then I said here is equal to this, is that later I want to do simulation. Okay, what if total fixed cost is 25,000? Then the model will automatically bring the picture. You do not have to go and recalculate anything. That's why I'm doing it like this. So this is what we call self-referencing, and it gives you the full flexibility of doing sensitivity analysis. So this is it, and then I can drag this across. Because I said it should be an absolute sale reference, you'll see that as I'm dragging, it will be the same figure. It's not going to be changing in any way. Okay, so that is it. 20,000, 20,000, 20,000. That is the nature of fixed costs. Now our total cost is equal to fixed cost plus variable cost. So it's equal to this one plus this one. Total variable cost plus total fixed cost, or total fixed cost plus total variable cost. So at output 0, our total cost is our total fixed cost. There is no output yet. So when we drag, we get our total cost, which is a combination of our fixed cost and variable cost. And that is up to the last unit. I just want to add, this is basic Excel. We are not doing any Excel yet. But you just look at the power that the application has. Imagine you were doing this manually using calculator, punching. Look at the quantities I just dragged across in just a split of a second. You cannot do same. Yes, sir, I'm listening.
Would UCC system allows, not purposely for our exams, but would they allow this system to be used in an examination?
For now, the university is quite traditional, and that is not good. So we cannot.
But that's why they use it.
We cannot set.
Hello?
Yeah, Raymond, please, I'm listening to you.
Yes, sir. I am saying that that is rather
very unfortunate, because we are far behind time.
They use it, because when we go to our various workplaces, these are the softwares
this is the basic
that are
software
used for our day-to-day practice.
So the fact is, you come to what we call an institution of higher learning. This is the center of all knowledge in the country. and then the knowledge that we need for industry, we don't learn it here. We learn something else. So you can understand why it is like that, but in fact, I don't have the answer. So that's why I entreat people to help yourself, because I don't understand anyway. But you can help yourself. These things are not too hard to learn.
But at least we will be using this software during the training that we are
And
about
even
now.
if the university will not be so much interested in teaching like this at the regular undergraduate level, this is a must for your level. Most of the participants in this type of education sandwich, people already at job places. Most of them even hold managerial positions. Others, even if they don't hold managerial positions, they prepare reports for their bosses and they use this. So the learning should be just around the things they use. The learning should help them do their work at their job places better, efficiently. But if you go and stand on some blackboard or whiteboard and do that archaic thing, that's a problem. Okay, and we know that our operating income is equal to our revenue minus our total cost. So at output 0, your profit will be negative 20,000. That's your fixed cost. You will make a loss of your fixed cost. And when you drag, you now begin to see where profits are coming, where losses are. It's like we are making all losses. So I'll change some of the figures, don't worry. Let me even select this and go to cell size. Okay, so fantastic. So this is the picture we have. With these variables, input variables, selling price of 100, variable cost per unit of this, fixed cost of this. This is the picture. In terms of our total revenue, total variable cost contribution, our eye is more on contribution, and then maybe total cost and operating income. You realize that the bottom column is showing all negative, because with this, at this level of output, with our cost and revenue structure, we have not even had revenue. We can extend, because when I was doing the analysis, I did to about 1,000 units. So let me just drag and see how I'm doing it. I'm picking all of them and dragging, so I'm not going to do it line by line. Oh, damn it, this one is going to give me a problem. So let me do it like this and see if it will work that way. Okay. That is fine. So I maintain the 10-10 difference. So let me do up to about 800. Okay, so this becomes the new picture.
Hello,
Yes,
sir.
sir.
Please, you mentioned that the operation income.
Yes, I'm listening.
Okay. That is revenue minus the fixed cost.
No. Operating income is revenue minus total cost.
Revenue minus total.
Yeah, that's your income. Total revenue minus total cost.
Okay. But when we were inputting the formula, I think
the formula was done wrong. Let's see the formula.
Yes. Quantity.
Oh, sorry. Okay, so this is how you can also modify the formula. You click inside where the formula is, then you can click in the formula bar, or you can press F2. It takes you to the edit mode. So you will see the cells that were picked for building the formula. The program uses colors to code them. So say this is blue, this is red, so it circles them for you. So if this one, I picked the wrong cell, right? So I can come and handle it. If I hover my mouse around the borders, you see this cross, it means I can hold and reposition it, so I can take it here. Once I do that and press enter, the formula will recalculate. But what it means is that it is only this one which will be correct for now. I have to drag it again across for it to be correct. Thank you very much. So because I was worried about the figures still showing negatives. Yeah, because the calculation was wrong. Good. So now that we have the correct formula done, and assuming if you were doing this manually and you later realize you made this mistake, look at the amount of work you will have to do, canceling everything. This one, you just change it and it recalculates almost everything for you. Okay, so let's see. Let me try to freeze here so we can see things well. Let me click here and go to view and then freeze panes. Let me freeze panes. This is not what I wanted to do. I want to freeze the column. So freeze first column, okay? So that we can see the labels as I drag. So at the various quantities, quantity 20, 30, blah, blah, you see all the figures. You see total revenue, total variable cost, contribution. Then you know that at the break-even quantity, total revenue is equal to total cost. And that operating income is 0. So as you drag, maybe you want to have your eye on that. All of this region, all of these quantity regions up to 170 now, they are all quantities when we are producing, we get lost. We are not able to cover our fixed cost, but at least we get some contribution, positive contribution towards recovery of the fixed cost. So you see, as we go, the contribution is increasing to reduce the loss. We are now paying the fiscals, to reduce it. So we do that up to a point like here, 500, and then you see that operating income is 0. This is how accounting we write 0 dash. Operating income is 0. Where operating income is 0, the point is that your total revenue, which is 500, is equal to your total cost, 50,000, which is also 50,000. So you are able to just pay for all your costs, your variable and your fixed. Nothing is left. So this is the break-even quantity, 500. If you use the formula to calculate based on these same figures, you get your break-even quantity to be the same 500. But the formula is that you get you get the figures for what you're interested in. You will not get all of these quantities and all the figures they are producing. That's the beauty of the spreadsheet. So you get a full picture if you want. Then beyond this, you begin to make positive profit. So we make profits from 510. So this is where the safety line is drawn at quantity 500. So if you made a sale of 510, your margin of safety is 510 minus 500, which is just 10 products. If you want to compute it in percentage, you can do so. If you want to use the total revenue to do that, 51,000 minus 50,000, which is 1,000, and so on and so forth. So beyond 500 quantity, you see that all the other quantities are producing positive operating profit up to here. That's what it is. And this one, you do it at very much speed and accuracy. And on top of that, you can see it in chart. I am modeling the spreadsheet break-even CVP charts with spreadsheet with Excel. When you go and read, you can see how it is done. We don't have time to do the paperwork because managers don't do paperwork. They do this thing I'm doing. So I can do, I can model, I can do a chart to see how it is doing. Maybe at beginning, I want to see my total revenue, and my total cost, how they compare in terms of charts. So I'll select the total revenue line. Okay, I did up to 800. And I'll control select the total cost. Control select this one. Of course, I can pick all of them and do a chart on, but I want to show you step by step. So I come to insert, because I want to insert a chart, and let me do a line chart. Okay. So you see something like this. Let's do it one by one. So let me move it to its own chart sheet. All right. So this is how they compare. So you see the legend, total revenue is the blue line and total cost is the, let me call it red line, even though it's not red. So you see where they cross, where they have intercourse is where break even is giving birth to. Okay, so this is the basic break-even chart. The total revenue line, the total cost line, where they intersect is the break-even point. When you trace it down to the quantity axis, and of course, this one is going to use a scale.
8, 7.
Hello, a question? Yes, I'm listening.
8790.
What is 8790? Are you listening to what I'm doing? I'm saying.
So the person is not in the lecture. He's
so why is he
to someone
disturbing us?
else?
Okay, no problem. So this is the break-even chart, total revenue chart, total cost chart. Where they cross, we get a break-even quantity. So you will trace it back to 500, but this one uses a scale, so you have to know the scale. Maybe 1 centimeter is to maybe 100, so you can 5 will be for times 100 for 500, because the figures are big, so it has to scale to fit the graph. And the break-even sales, so this is the vertical axis. This one is the money. The break-even sales when you trace is 50,000. You can add the others to it. For example, if I go back to the sheet and then I also control select, let's say, total fixed cost. So I want to add total fixed cost to the graph, to the equation. Okay. And I do the graph again. Let me do the graph again. Line and this. Okay, let me move it to its own chart so we can see it well. Chart sheet 2. Okay. So you will see that the red one is the total fixed cost. The legend is below. Let me try to zoom it a little and go back here. Yeah. Total revenue is the blue line. The pink or what, the orange color is the total fixed cost. And then the ash one is the total cost. So total cost will start from not 0, because without even production we have fixed cost to cover. So you see the total fixed cost starts from 20,000, the total cost curve. It joins with the total fixed cost here, and this is our total revenue line. We have only added total fixed cost to it, and you see it to be perfectly horizontal because it doesn't respect the output. You can produce 1 million, that cost is the same. So it's the same across all the numerous outputs here. It's the same at 20,000. And here, this region, let me see if I can write. Okay, I can do that. This region, between the total cost line and the total revenue line. The total cost line is the ash one, the total revenue is the blue one. This is the break-even. The break-even point. When you trace it down, you get a break-even quantity. When you trace it here, you get a break-even sales revenue. So here, down, takes you to about 50. I think every unit is 500. Here takes you to this figure. So this is a break-even revenue, break-even quantity. The region between the two curves below this point are all loss regions, because at this region, total cost curve is lying on top of the total revenue curve. In other words, the total cost curve is bigger than the total revenue curve, giving you a loss. But above, so that is below, but above, you will get revenue, because total revenue curve is on top of the total cost curve. And this is the profit region. Profit region, this is loss region. And this is the center. So a measure of how far you are from the center, right? A measure of how far you are right-wise from the center is what we term as your margin of safety. So between here and wherever you find yourself is your measure of margin of safety at that point in time. Any question about what we have done? My class, are you sleeping?
Yeah, this one I'm not getting it.
You are not getting it.
Sir, please.
I had
I said,
network challenge.
So you are
I'm
not seeing the
getting
video.
it. I've seen it. I've seen the lines that you've drawn, but I can't explain.
But you know, you understand the figures, these figures, right? How we generated them. And you understand the logic behind this modeling. It is the modeling that we are trying to show in graph, because managers may not have so much time. Sometimes they see the graph, they get the overall picture. Before, if they get time, they go and look at the details later.
Before the conclusion of the figures, I had a network challenge, so I just joined
Okay. That's not a problem. I'll upload the video there, or you can ask your questions during the face-to-face session, all right? But those who were part of the class, any questions so far about doing break-even charts? First of all, modeling the break-even analysis in Spreadsheet and doing break-even charts with Spreadsheets. Any question? Yeah, Charles.
I think we are quiet now because of the time.
Okay, so let's stop here. At least we have the basic understanding. When we go and read over, watch the video over, and then practice more, experiment with our own machines, we will realize it is very, very simple. You can also go to YouTube and Google, just search for a video about how to do this. If I get nice ones, I'll also share with you on your platforms. Okay. So this is where we will end the lecture if you don't have any question. Yes, sir.
I will try and see you before our next class to pick the rest of the
Okay, sir. Okay, thank you very much.
Okay.